Here we go. Group test mod 22. Mod 22 test is a 50-point test, and it is tomorrow. All right, determine if each scenario depicts a survey, observational study, or experiment. Now, depending on which one of these three things it depicts, determines what else you have to give me, right? Now, a survey is simply asking a question, right? Something like that, or recording a piece of information. An observational study has to have a factor, meaning something that you're going to compare in it, and a characteristic of interest. So, let's see. A preschool teacher records the sleeping habits of the students when they take a 30-minute nap after lunch. Are there any treatment things there? No. Nope. So, what have we got going here? We have a survey. So, when we have a survey, we do need to identify the characteristic of interest. Now, some of you put survey into your computer answer, and then you didn't put the characteristic of interest. Or you put the characteristic of interest, but you didn't tell me first that it was a survey. You have to have both things. So, in your computer, you need to type survey, and then you can just put COI. What is the characteristic of interest? Sleeping habits. Now, I'm not an English teacher. I don't need a whole paragraph. You can literally just write survey, comma, COI, sleeping habits. That's completely adequate for me. All right? A preschool teacher records the sleeping habits of students while they take a 30-minute nap after lunch. She compares the sleeping habits of the students who brought a pad to sleep on with those who brought only a blanket. What is this? This is clearly more involved than a survey. Is it an observational study or an experiment? Is there a treatment that the teacher is imposing on the people? No. If there's no treatment, it's not an experiment, it's an observational study.
So, if it's experiment, it has to have a treatment?
Yes. So I have an observational study. What do I need to include? The factor. What is the factor? What differentiates one group from another group? Blanket or pad. I also need the characteristic of interest. What's the characteristic of interest? Still the sleeping habits. So what I have written on my paper is all you need. And truthfully, I made it so that you could just hit enter after each one. So if you put each one of these on a different line in your answer, so hit observational study, enter. Factor, blanket or pad, enter. Go to the next line. So if you just put each of them on a new line, it's perfect. That makes it super easy for me. A teacher provides half her class with fill-in-the-blank notes as usual, and the other half of the class takes notes on their own paper. She then compares the students' scores on the next quiz. What have we got going on here? Experiment. How do I know? The teacher is controlling who gets what. Therefore, there's a treatment. So, I need the treatment. What is the treatment that's being given here? What's the thing that's abnormal? Which one, though? Can't be both. Only one of those is the treatment.
It's the ones on the own paper.
Taking their own notes.
Wait, why would that be the treatment?
Because it's the one that's out of the norm. It says fill in the blank notes as usual, therefore that's going to be what they're used to. That's not something that's different. Let's see, what else do I need? The characteristic of interest. Is the characteristic of interest the notes? Quiz scores. Okay. And then we get into the different groups. We have a treatment group. And some people put in the treatment group as half the students, and then the control group, they put the other half of the students. That doesn't work. You have to be more specific than that. Which group would be the treatment group? Students taking their own notes. And the control group, students with fill in the blank notes. And you can't just say fill in the blank notes there, because that's not the control group. The control group is the students that are given the fill in the blank notes. Make sense? All right. A preschool teacher usually has all her students take a 30-minute nap after lunch on a blanket on the floor. She decides that for her Monday, Wednesday, Friday class, she will also purchase a small pad for each child. She records the sleeping habits of the students in the Monday, Wednesday, Friday class and compares them to her Tuesday, Thursday class. What have we got here? Experiment. So I got to put all this other stuff in here. So, what is the treatment? What treatment is being given that's out of the norm? Sleeping pad, right? What's the characteristic of interest? Sleeping habits. In other words, everything she's doing is so that she can evaluate sleeping habits. That's your interest. Treatment group. Some people just put Monday, Wednesday, Friday class. It's easier for me if you just say students with pads. And the control group. Please don't put the rest of the students, because it does show up as a separate question on the computer. Put students without pads. Okay. Questions there? Yes?
How many of these are going to be like on the test, like the same, like just question 1 and then ABC?
Yep. The test very much mirrors this, just different scenarios and different numbers and such. All right. Catherine owns a small online business. She wants to know the mean amount of revenue on her website per day. She is aiming for a 95% confidence interval and a margin of error of $110. So I've got some important information there. That right there is E. Remember, capital E means margin of error. Oops. So my margin of error is $110. 95% confidence interval means I have Z sub 95, right? And that's one I have to get off my formulas. So on the back, what's Z sub 95? 1.96. Okay. Let's see, what else? Given that the population standard deviation, right there, standard deviation is 235, what sample size should she use? Whenever we're trying to find the sample size, we are always looking for n. Okay? So, I want to find a formula that has n by itself, because that's what I'm looking for, right? So, there are two formulas that have n by itself. There is this one right here, and there is that one right there. Which one do I use? Why? Because it's mean. Because I want to know the mean amount of revenue. There should be a keyword there that tells you which one you're using. So, I'm going to use that formula. That was n equals z sub c times the standard deviation all over the margin of error squared. So if I plug in my information, that's going to be 1.96 times, my standard deviation is 235, divided by my margin of error, and all of that squared. So let me grab my calculator. Okay. 1.96 times 235 divided by 110 and squared. Gives me 17.5 or 17.53. Now let's talk about this for a minute. Sample size. Sample size is how many she's going to survey. So if she wants to know how many, she wants to know the average amount of revenue per day, this is telling her how many days she needs to survey in order to get the result she wants. So she could not guarantee a 95% confidence interval and a margin of error of 110 days, or of $110, sorry, if she didn't use the appropriate sample size. So if this says 17.53, she's not going to get it if she does 17 days. She needs to look at 18 days for her sample size. Now, many of you got the 1753, you just labeled it wrong. This is a number of days that she has to record data from. Or if it was people, it would be a number of people that have to be in her group that she has to survey. Okay? Now, it says include words in your answer. Days is adequate for including words in your answer for me. Okay? Questions there? All right. Next page. Suppose that a school board wants to know the effect of increasing the number of hours of math instruction per week on state math testing for children. What is their ultimate goal? What are they wanting to evaluate? State math testing. So my characteristic of interest? Is the results of the state test. Now please note as you're going through this, this is A and then this one is B right below it. That would be my answer for C that I just got, and then we have D. So what's the treatment? Half the fifth graders in an elementary school selected at random were given 2 additional hours of math instruction per week throughout the school year. There's my treatment. 2 additional hours of math instruction. So, what is the treatment group? Students with extra instruction. What is the control group? Students without extra instruction. Yeah. So, suppose that a doctor designed a study to determine whether eating an apple daily will decrease the number of doctor visits that his patients have over the course of the year. I do. Sorry, let me unfreeze it for you. There we go. We better now? Okay. First off, what is the null hypothesis for this scenario? What is the doctor trying to find out? Does eating an apple affect the number of doctor's visits? So the null hypothesis would be eating an apple a day has what? No effect on the number of doctor's visits. Right? The treatment has no effect on the characteristic of interest. Yes?
How do you find the null hypothesis?
The null hypothesis is always that whatever treatment is for the scenario makes no difference on the outcome you're looking at. So if I were to come back here, an experiment, let's see, this is the one with the sleeping pads and whatnot. The null hypothesis here would be that a sleeping pad does not affect sleeping habits.
So it's always doesn't?
It's always yes. The null hypothesis is that whatever it is that you are giving to the people participating is not affecting the outcome at all. Meaning, null means nothing, meaning nothing happens. Okay? Now your goal is that something happens, usually. But the null hypothesis is that nothing happens. All right, yes?
What if you put in eating an apple won't decrease the number of doctors visits?
What if you put eating an apple won't decrease? That's not enough, because the null hypothesis, that leaves it open for increasing. And increasing would be not a part of the null hypothesis either. So you could say it doesn't increase or decrease. That's fine. But you can't just put one, because it leaves the other one open. So the difference of the means for the two groups, the mean of the treatment group and the mean of the control group. So 4 plus 7 plus 2 plus 5 plus 7 plus 3 plus 0 plus 2 plus 3 plus 5 happens to be 38. Divide that by 2, 4, 6, 8, 10 numbers, and I get 3.8. Treatment group, 5, 9, 2, adding all those up, you end up getting 45. Divide that by 10, and you get 4.5. So if they want me to take the mean of the treatment group, that is 4.5, and subtract the mean of the control group, that's 3.8, I get a result of 0.7. I think every group got that right except for the one group that put a question mark. Now, this number right here is positive. Correct? It's not always positive. But in this scenario, it's positive. So what does that mean? That means that eating an apple a day increases the number of doctor's visits. Seems kind of strange, doesn't it? You can't go with your logic. You can't go with what you think. If this number was negative, that would mean that it decreases the number of visits. So, state a conclusion. Eating an apple a day will increase the number of doctor visits per year. Now, some people were trying to say whether you reject the null hypothesis or you accept the null hypothesis. We don't have enough information for that. We're just making a conclusion based on what this number was. If this number was 0, then that would mean apple a day doesn't affect the number of doctor's visits. If this number was negative, that would mean eating an apple a day decreases the number of doctor's visits. We don't know how much it increases them. We just know that the mean increases. All right. Suppose that at a large high school, the average final exam score for IM3 students who were given the final review worksheets 3 weeks early was 79, while the average score for all other IM3 students was 73. What is the difference of the means for the two groups? I'm going to follow the same pattern as up here. I want the mean of the treatment group minus the mean of the control group. What would the treatment group be? The ones who got it early, which was 79, minus the treatment group, minus the control group, which is 73, and that is 6. The resampling distribution of mean scores, given that the null hypothesis is true, is normal, with a mean of 0 and a standard error of 4. What interval captures 95% of means in the resampling distribution? Do you remember that 95% is that 2 standard deviations out on either side of your bell curve? If you have the mean in the middle. So if I were to think about this like the bell curve, if the mean was in the middle, what's the mean that they tell me? 0. and the standard error is 4, so that would be 4, 8, -4, -8. And there is another line out there, but we're only concerned about that one. So I would say -8 to 8. Some people wanted to type in -8 is less than or equal to, just write -8 to 8 is fine. Or you could say between -8 and 8. That is equivalent to -8 is less than or equal to x, which is less than or equal to 8. Okay? Is there enough evidence that the additional time given for the review raised students' final exam scores? Well, what result did we get? We got 6. Is that within this range? It is, isn't it? So, because 6 is between -8 and 8, the difference is not significant.
So if it's in between, it's not significant?
Correct. Because this is where 95% of results would end up. We would want to see if our treatment actually had an effect. We want our result to be outside of what's normal, not inside what would be expected anyways. Okay? All right, last page. Suppose that a survey of a random sample of 200 employees of a large company found that 150 employees carpool to work. What are the values for n and, I know this is kind of hard to tell, but it's p hat. What is n? 200. That's how many are in your sample. P hat. That's 150 out of what? 200. A lot of people just wrote 150 for their p hat. Can't do that. P hat is a proportion, which means it's a fraction, percent, decimal, that kind of stuff. Now, here's my one thing. If you put this as a percent, your answer to part C should also be a percent. If you put this as just a decimal and don't go to percent, your answer to part C should also be a decimal. Don't switch around. I prefer percents just because I think they're easier to grade. But 150 over 200 is 0.75, so I accepted 0.75 here, or I accepted 75%. Okay? You do not need to put both there. One is adequate. What is the value of the standard deviation of p hat? Well, that's going to be a formula I'm going to need to use. Standard deviation of p hat, where's my formula? Right there? That's the formula I'm using. So, the standard deviation of p hat is equal to the square root of p hat times 1 minus p hat all over n. So for our problem, that would be the square root of 0.75. Now it is key that even if you put it as a percent here, you can't calculate with a percent. You need the decimal. Times 1 minus 0.75 all over n, which is 200. And when you solve that, you end up with 0.0306. And I'm going to stop right there. The next decimal or the next digit's a 1, but it says round to 3 decimal places. So 1, 2, 3. I have to look at the fourth. That 6 means this 0 is going to become a 1. So I'm going to put 0.031 as my answer. That is not a percent. It's just the standard deviation. What is the 90% confidence interval for the proportion of P employees, or the proportion P of employees who carpool to work? Again, round to 3 decimal places. So, that's the one where I've got that guy. Because I'm dealing with proportions. I'm up here. I need to take p hat and subtract z sub c times sigma sub p hat. So p hat minus z sub c times sigma of p hat is less than or equal to p is less than or equal to p hat plus z sub c times sigma of p hat. So, what is p hat? 0.75 minus z sub c. We're looking for 90%, so z sub c is 1.645. 1.645 times the standard deviation of p hat, which is what I just found, 0.031. That's going to give me this value that's on the left side of my interval. Do you get that? Good answer. 0.75 minus 1.645 times 0.031, and I get 0.69900. They want 3 digits, so I'm giving 3 digits there. It's less than or equal to p is less than or equal to, on this side it's the same exact thing, it's just a plus sign. So I'm just going to arrow back rather than retyping everything in. Find that minus sign and change it to a plus. And I get 0.8009 makes that 801. Right? Yes? So, since it says 3 decimal places, I have options. If I put a decimal here, I need to write 0.699 to 0.801. And I'm not writing it in that form because in the computer you're going to have to write it like this. If I wrote this one in percent, I need to say 69.9% to 80.1%. Does that make sense? Okay. All right, suppose that a group of researchers surveyed a random sample of 500 households in a town to find the percent of households with more than one car. They found that 81% of the households have more than one car. What is the standard deviation of p hat? Well, we used that formula up here, didn't we? Standard deviation of p hat. So we're going to use that same formula here. I need to know what p hat is. And what is p hat here? 81%. So 0.81, because I have to calculate with a decimal. I'm going to go there. And I also need to know n. What is n? My sample size, what is that? 500. So the standard deviation of p hat is equal to the square root of 0.81 times 1 minus 0.81 all over 500. And when I do that on my calculator, I get 0.0175. Round to 3 decimal places. So 1, 2, 3. What does that 5 do to the 7? Makes it an 8. So that's my rounding. I have 0.018. What are reasonably likely values of p that fall within 2 standard deviations of p hat? Again, that's p hat again. Does it tell me a confidence interval level? No. It doesn't say 90%, 95%, 99%. If it just gives me something that says reasonably likely or something like that, that's where I just add and subtract 2 standard deviations. So I'm going to take my p hat value. I'm sorry, my p value. 0.81. I'm going to add 2 standard deviations, and I'm also going to subtract 2 standard deviations. What's my standard deviation? 0.018. So 0.81 plus 2 times 0.018 is 0.846. And on the minus side, again, finding that plus sign, change it to a minus, 0.774. So I can either say 0.774 to 0.846, or I can say 77.4% to 84.6%. Now, you always want to put the smaller number first on these. You always want lower number to higher number. Questions on that one? Okay, suppose that a survey of a random sample of 300 customers at a restaurant found that the mean price for an order was $35.55. $35.55. I'm filling that in because that's my mean. The store manager knows that the population standard deviation is 950. You could put 9.50 or 9.5. What was the end value? 300. What is the value of sigma sub x bar? Well, there's a formula, I think, on the back. Sigma sub x bar. Right there. That's the formula I'm using now. So, oops. Sigma sub x bar is equal to the population standard deviation divided by the square root of our sample size. So that'd be the square root of 300 on the bottom. On the top, what's my sample standard, or my population standard deviation is 9.50. So that's what I'm calculating. 9.5 divided by the square root of 300. And I get 0.5484. Rounded to 3 decimal places, 1, 2, 3, that's a 4. So it's not going to change the 8. So I have 0.548. Now let's look at this for a minute. I want to address a rounding thing. Because after this 4, it's another 8, isn't it? And some people say, well, doesn't that 8 make that a 5, and that 5 then makes that a 9? We can't round based on numbers further down the line. Because if you want to think about it, this is 48. Yes, 48 rounds to 50, but 48 is not closer to 900 than it is to 800. Does that make sense? So you only look at the number next to it. You don't care what that one would do to that one. That's just going too far. Okay, what is the 99% confidence interval? I have a feeling I'm going to need Z sub 99. And from the back side, that is 2.576. 99% confidence interval for the mean price for an order at the grocery store. And it says round to the nearest cent. So this one, my answer does need to be in dollars and cents. So I'm going to take X bar, and let me show you what I'm following. I am now following this guy. I did it with the P hat ones. Now I'm doing it with the X bar ones. So I am going to subtract Z sub 99 times the standard deviation of X bar. And I'm also going to, what? This should be mu, not X bar. I'm also going to add Z sub 99 times the standard deviation of X bar. So, X bar was 35.55. I'm going to subtract Z sub 99 times the standard deviation of X bar, which is 0.548. And I'm also going to go back and I'm going to add that value. So let's see what I get. 35.55 minus 2.576 times 0.548. This one gives me 34 point, now we're doing dollars and cents, so if this says 138, that's 14, right? Only when we're talking about means do we talk about whole numbers and not percents. And then going back, changing that minus to a plus will give me the other boundary. That would be what? $36.96. So I have dollar sign 34.14 to dollar sign 36.96. Okay? That's a hefty problem. That's a 9-point problem. 3 points for part A, 3 points for part B, 3 points for part C. All right, suppose that a study is conducted by having the teachers ask their students if they have ever copied someone else's homework. There shouldn't be the word test there. Why are the results of this study likely to be inaccurate? Give me a reason why.
Because students never ask. Or tell the teachers that.
Students what?
Wouldn't tell the teacher, ask the teachers if they ever copied someone's work.
Okay, students might lie. Because they don't want to get in trouble, right? Does anyone remember what that's called? The interviewer effect. Based on who's asking the question, it's biasing the result. What other reasons could there be? Students just don't respond. Students might lie is probably the easiest one to come up with there. How could the accuracy of the survey be improved? Now, there's several different answers you could do here. Some people suggested make it anonymous. That's totally fine. You don't need multiple reasons, just give me one. Make it anonymous. You could also have students ask rather than the teacher. Changing who the interviewer is. Okay? And I'm sure if you were thinking long enough, you could come up with some other ones, but you only need to come up with one for that. Okay? Any questions? All right. Test is tomorrow.